that there are three charges placed at the vertices of an equilateral triangle. There are three charges placed at the vertices of an equilateral triangle. But what are we supposed to do? There is a fourth charge which is placed at the centroid of this triangle. Right? Let it be of magnitude Q4, for instance. Now you need to calculate what is the force experienced by this charge due to the remaining part of this. So wherever you have more than two charges, what is the thing that we are supposed to do? So if I take this to be A, B, and C. If I take it to be A, B, and C, and let me call it as D, for instance. Now, what is the force experienced by Q4 due to the charge at point A? What is the direction? But we have to prove it. How? That's what I mean. So, which way? Which side? It will act along the line joining the charges and it will be in the downward arrow. What's the name of it? So this is the fourth charge, 1, 2, and 3. So give a name to it. It's 4. So it is F4, correct. Right. So similarly, the force experienced due to the Q4 due to second charge. Right? What about this one? F4, 3. So if I draw a separate free body diagram, this is F42. This is F43. This is F4. Correct. Now the question is, what is the angle between each? It is 120. So 360 degrees. No, this is 120. This is 120, and this is 120. Am I clear with this? Now the question is, what is the value of F41? So what is the value of F4? 1 by 4 epsilon naught. Q into Q4. Q4. So Q into Q4 divided by. Now the question is, what is the distance of the centroid from each vertex? What is the value? Okay, let's take the side to be A. What is the distance? I'll give you a hint. You can use trigonometry. Use trigonometry. Simple. See, if I drop this, how much is this distance? It is A by 2. What is the angle inside an equilateral triangle? 60. This is an angular bisector, so this will be 30. So A by 2 divided by, if I take this to be x. So A by 2 divided by x is how much? Cos 30. How much is cos 30? root 3 by 2. So A will be equal to how much? So not A, I need X. X will be how much? A by. So A by 2x is equal to root 3 by 2. Is it clear? So 2 and 2 are gone. So X will be A by root 3. But I want to tell you one thing, most unwanted data in this question. I wanted to explain it to you because if the values are different, you will get stuck. In this problem, it is unwanted because all the charges at the vertex are the same. But had they been different, you should know what is this value. So next time you may not sit and calculate this one, you can directly write down the value. Okay, this A by root 3, I'll call it as X itself, for instance. Then if I take and substitute it here, what should I put there? Denominator, what should I put? X square, correct? Similarly, what about F42? One by 4 by epsilon naught Q into Q4 divided by what is that distance? Same X, no? So it is going to be X square. What about F43? 1 by 4 by epsilon naught Q4 divided by. So this is how it works. Now, if you look at the magnitudes of all the three, what are they? F41 is equal to F42 is equal to F43. I call it as F itself. Can I call it? If that's the case, this force is F, this force is F, and this force is right. F, F, and now what I'm going to do is I'll divide it into two parts. I'll divide it into the axis. Now, if I make it like this, how much is this angle? Obviously, a 90. Out of 120, 90 is lost. So, how much will this be? 30. So, you all know how to resolve a vector? How do you do that? How is the resolution of vectors? If anybody doesn't know, please let me know so that I can explain. It's not a crime to not know. Please let me know if you're not clear. Does everyone know? So, if this is the case, if this is A, then resolve this vector into horizontal and the vertical components, where this angle is theta. So, which one is cos theta? Which one is sin theta? Vertical. Okay. Horizontal is, but how did you find? Sorry. Very good. So wherever theta is there, right, adjacent to that will be cos. Right. Having said that, if this is 30, sorry, if this is 30 degrees, I need to resolve it into two components. What are the two components? So how should I break them? Very simple. In which quadrant is it lying? First quadrant. First quadrant x and y both are positive.
Positive.
Component will be to the right of if cos 30 and vertically it will be. Sorry. I hope I'm clear to this. What about this force? It's in which quadrant? Second, right? So second quadrant, which is negative. Sign. I'm not going into, don't get into the trigonometric factors. Tell me in terms of coordinate geometry. X-axis negative or y-axis? X is negative and y is positive. So, when the arrow mark is pointing into the second quadrant, you need to resolve them in such a way that the x coordinate is negative. How much is this angle? Same 30, symmetric. So how much will this be? F cos 30, and how much is this going to be? So which one will get cancelled? F cos and F cos are gone opposite and same magnitude. F sin and F sin, they get added. So what is sin 30? 1 by 2.
1 by 2.
F by 2, this will be F by 2. So the sum of these two is going to give me a F. So F in the upward direction and F in the downward direction also get nullified. So what are the net force experience for this? It's actually a simple problem. Only thing is we were discussing multiple mathematical aspects. If you have to summarize this and see, right, if you have to visualize how big the problem is, it's very simple. First, you write the Coulomb's law. You take the direction into consideration. Next step is resolve them into components and then add or subtract depending on further components. So next time, will you be able to do these components things faster? Right, I'll not take this much time to explain. I'll directly write it. Right? Please make a note of that. Start. Right. Next one. This one. Interesting. Yep. So shall we do the next one? If you see in this problem, I actually didn't apply principle of superposition. Right? We actually solved it using residuation itself. But if you want to apply principle of superposition, in this problem, it is slightly complicated. Why is it so? Because you need to find the resultant of these two, then the resultant of these two. That is another way of solving. Okay. Maybe I'll show you that method also. Whichever is easy, you can take it. Is this method clear to everyone? Of any resultant of any, it will exactly be the opposite direction of the other. So there I would like to stress on one point. Shall I do that and show? Right. So observe. How was the diagram? It was like this, no? This is F, F, and am I right? So how much is the angle between? Suppose I'm ignoring the third one. For this and this, I'm able to see that we have co-initial vectors. So there are two types of laws in vectors. One is called as triangle law of addition. Second is parallelogram law of addition. Okay. Logically speaking, they both are same, but the approach is different. Okay, we approach them in a different way. Yesterday I would have explained about triangle law. What did I say? Yesterday when I explained the vector laws, sorry, Coulomb's law and vector form. Right. What did I tell you? So if you don't remember, at least check your notes. If two vectors are taken in order, considering to be the two sides of a triangle, then the resultant is given by the third side of the triangle taken in the reverse order. You remember that, no? So you will apply triangle of addition of vectors when you have two vectors which are in continuous direction. What do you mean by continuous? When the end point of the first vector is a starting point.
Of the second vector.
Okay, whereas when you have two co-initial vectors, what do you mean by co-initial? Starting point is the same. Co is same, initial. So when the starting point of two vectors is the same, you can apply parallelogram law. So what does this parallelogram law of vectors state? If at all I have one vector A like this and another vector B like this, and the angle between them is theta, then I have a root of A square plus B square plus 2AB cos theta. I hope I don't hear this. So this is actually an alternate. Now, for this one and this one, Sanjay, can you tell me how to apply this? Square root of, in the place of A, what do you have? F square. In the place of B, what do you have? F square plus 2 into F into F. So what is cos 120? Minus, correct. So square root of F square plus F square plus 2F square into cos of 120 is minus half, 2 and 2 are 1. So F square and F square are 1. So what is that you're left out with? You're left out with F. Got it? So you're left out with F. Here comes an important question. Whenever you have two co-initial vectors, you apply the parallelogram, right? You get a resultant. The question is, how is that resultant with respect to either of the vectors? What is the orientation? Right? In vectors, they call it as direction. Okay. What is the angle made by the resultant with either of the vectors? In this case, observe, if at all I have two vectors which are of same magnitude, and if the angle between the vectors is taken to be theta, then the resultant is always an angular bisector. The resultant is always an angular bisector, but the resultant always need not be A. In this case, it is F, but it is not necessary every time it will be F. Here it is F because of 120, or else this 2 and 2 would have not got cancelled. So what is the answer? The resultant will be in this way, making an angle of 60 here and so this F is exactly opposite to this F, and they get cancelled, and still the answer is going to be a 0. So whichever is easy, you can take it. Right. This is just an alternate method. Right. Which one is easy actually? So just one here, this one. But resolution will help you in one of the derivations in this chapter, so that time you'll understand. Hariharan and Divya, is it clear?
Yes, sir.
We proceed. Shall we proceed to the next one? Right.
Yes, sir.
So the next problem is something similar, but I want you people to think. I want you to do it. I'll do for one scenario and show. For the remaining two, you have to do and show. So, can I have the question? So, example 1.7 says, consider the charges Q, Q and minus Q. Okay, Q, Q and minus Q placed at the vertices of an equilateral triangle as shown in the figure. So, Q, Q and minus Q. They are placed at the vertices of an equilateral triangle as shown in the figure. Right. So this point is given as A, this is given as B, and this is given as C. Now the question is very simple. What is the force on each charge? It's very clear. So what do you mean by the force on each charge? The force experienced by each charge due to the remaining part of the system. Correct. So I'll do for A. See, if I take the charge at A, right? So due to the charge at B, what is going to be the direction in which it will experience the force? Leftward or rightward? So positive charge, this is also a positive charge. In which direction will it experience? Ezra? Leftward. Okay. So let me name them as 1, 2, and 3. So what will be the name of this? F 1, 1, 2, F1, 2. So due to the charge at 3, what will be the direction in which it experiences? F13 is fine. In which direction will it experience? Towards. This is what you meant, right? So what the angle here? 120. So again, it is an equilateral triangle A, and A. Now, what is going to be the value of F12? K Q square divided by A square. Am I right? 1 by 4 pi epsilon naught into magnitude of the charges divided by the square of the distance of separation, A square. So what about F13? Tell me the answer. K. So Q into minus Q, it is minus Q square divided by A square. This is one common mistake that you people do. What is the thing I stressed on Coulomb's law yesterday? Force is directly proportional to the product of magnitude of the charges. So in this chapter, wherever you have vectors, and for those vectors, wherever you have already mentioned the direction, don't take the sign of the charge into consideration. There is one important point I want you all to know. So you don't take the sign of the charge into consideration. So what will you write? You will write it as K into Q square only divided by A square. So if I observe, both of them have the same magnitude. Am I clear? So did you understand what is the common mistake that you people do? So if I call that to be F, so this is F and this is also F, and how much is this angle going to be? 120. Am I right? What are we supposed to do? Result, and what will be the answer? Apply the parallelogram law of vectors. We already did it in the previous problem itself. In this slide, I did it. No. F and F at an angle of 120. What was the result? It was F, right? So here also it will be F only. And what will be the angle made by it? Simple. That's it. So the force experienced by the charge at A will be F, making an angle 60 degrees with AC. That is how you need to report the answer. So how will you report it? It is experiencing a force of magnitude F at an angle of 60 degrees with. Here. So the next two, you guys need to solve it. I'll give you exactly 5 minutes. Do it. What is the answer for B? B. For B. Okay. How will you report the answer? You're talking only about magnitude. I told you. I asked you how are you going to report the answer. It is experiencing a resultant force of F at an angle of 60 degrees. That point is important. If you don't write that, you lose. First, see what is the difference. 2, 3. A is the distance. 2, 3. What is the name we give to force? Root 3F. 3F. A square F. Root 3A is just the distance. So 3F. At an angle. This will be how much? F. Okay. Final values. Okay. What is the name for this? F. 2, 1. What about this? F23, F21 and F23. What is the magnitude of them? Same F. Right. How much is this angle? 120. What will be the resultant? Resultant will be F, making an angle 60 degrees with whom? With these. Still have it up. Which step is not? See if you have this. Either one. It's upward only. Upward in the sense, it is always along the line joining both the charges. So this is the line joining. It should be along the line. Why upward and below? Any question? Sure. Okay. So what about third one? Correct? F. Magnitude of them. Same. Magnitude is same. A square, B square. Right. So what is the angle between them? 60. It's interior, no? Right. So these two are the coinitial vectors. Where will the resultant be? Exactly an angular bisector. How much will that value be? Value, not angle. So if R in the case of C, I'll write it as FC. FC will be root of F square plus F square plus 2 into F into cos of. So what is cos 60? 1 by 2. So 1 by 2 and 2 will get cancelled. No, it get added. In the previous case, it got cancelled because it was minus R. F square plus F square plus F square. 3F square under a root will be distance. So root 3F making an angle 30 degrees with AC or BC, whichever you report instead. Force supply. Positive charge. For example, this is positive charge. This is a fixed position. Okay. This is a negative charge. What will this slide do? Will it pull or pull up? So, due to this charge, it is experiencing a force in this direction. Another direction as well. So, this is what charge. So, what will this positive do to the negative? It will pull. That is why I put the arrow mark. I hope I'm clear, right? So with this, we have come to the conclusion of the concept of force.